we're going to start this first, then we'll use homecoming as a break. It'll give us a break. All right, so similar to what we did on Thursday, we're going to be finding common denominators. We're going to do some problems like we did on Thursday just to make sure that we can do them. And then we're going to do some of the more advanced problems where like this is the whole point of us doing this sort of unit. On this sheet, we're going to start off just by finding the common denominator, and then we're going to do some more work. So leave yourself a little bit of space in between each problem, because we are going to come back and add some more to this in a little bit. Okay, so leave a little bit of space. Alright, so for just the first one, it's okay if you didn't have time to write down the other two because I'll show them in a second. But if we just look at the first one, how do we start off finding a common denominator? Do you guys remember? Yeah, so you're looking for what multiplies to make that bottom. So we're factoring. We're factoring the denominator. So how do you factor 6? 3 times 2. How do you factor xy squared? Times x times y times y. Okay. How do you factor 4x squared y?
2 times 2 times x times x times y.
You guys didn't know this, but all Katie did all weekend was do denominators. She was like, this is so fun. This is so fun. Right, Katie? That's all I did all weekend. I was like, why would I do anything but math? Math is so fun. Yeah. All right, so if we start to write our common denominator, what do you guys think needs to be in our common denominator?
2.
Okay, we need a 3. 2 2s. How do you know you need 2 2s?
Yeah.
This side only has 1, this side has 2. So we need 2 of them.
Or one who got more wins.
Yeah, the one who has more wins. All right, how many x's do we need? 2, because this one had 2, that one only had 1. So we need 2 of them. And 2 y's. Yeah, this one had 2 y's, the other one only had 1. Lots of pairs in this problem. So 3, the 3 is by itself. 3 times 2 times 2 times x times x times y times y.
12x squared y squared.
Okay. All right, let's look at the second one. So this one had a 2x plus 1 on the bottom, and then a 2x on the other one. So then, to make these the same, I would just be like, oh, plus 1, right?
No.
Oh. Are you taping this? I'm taping this.
I'm taping it. I'm taping my camera.
I'm taping it for, you're doing it because you can't see.
Yeah.
Oh my goodness. Because your glasses aren't here?
Yeah, they broke.
Why don't we just move your desk up there so you can see? She doesn't want to look weird, so she's just holding up her phone instead to use it as a magnifying glass. All right. So this one has a plus in it. What does that tell us to do?
Parentheses.
Put parentheses. Is that what you're going to say? Oh, what's the question?
So, for number 1, did you get 18 or 12?
We got 12.
Can you explain how you got 12?
Yeah, so we did, if, you got it? Okay. All right. So for this one, I see a plus. I see a plus right here. What does that tell me to do?
It's parentheses.
Parentheses, that's considered to be a group. So is this 2x the same as this 2x? No, they are completely different factors. How many factors does this denominator have? It's got one factor. It's in parentheses. It's one factor. What's the one factor? 2x plus 1. It's a whole group. How many factors does this one have? 2. It's got a 2. It's got an x. They're different. Okay? So this one, if I say the factored form, I'm going to say that's just 2x plus 1. That is one factor. Over here, I got 2 times x. I got 2 different factors.
2 times x times 2x plus 1.
Yeah, so our common denominator, we got 3 different factors here.
So we use 2x.
So we need a 2, we need an x, we need a 2x plus 1. They're all different factors. They look similar, but they're not. We need a 2, we need an x, we need a 2x plus 1.
I have a question.
Yeah.
So how come the one that's in parentheses, how come you didn't break it down into 2 times x times 1?
The reason we didn't break it down is because anytime there are pluses and minuses, we put parentheses around it, and then we know that our factoring for those problems is only GCF, diamond, difference of squares, and then slide divide, which I will probably not throw at you too often. Okay? So once we put parentheses around it, we have specific types of factoring we're allowed to use.
Slide divide was hard for me on a quiz.
Huh? It was hard?
It was hard. I didn't know, like, because I don't know, when I was looking like at my notes and stuff, it was saying something.
Yeah.
Wait, I don't know. I was just so confused. But I tried.
That's good. All right.
I know that each one was different. I placed it the same for like language.
I never know what to do after I divide and bring it, just put it for the x.
So maybe we need to put it on a warm-up
I
tomorrow?
think I divided. I think I multiplied.
Yeah. Did we distribute? No, we did not. You just leave it like that. Okay, go ahead and take a moment. Try number 3. I haven't done the problem yet. I'm not sure what it is. I think it's... What did you say your common denominator was? You're going to need 3 3s. Yeah. Because one side only had 1 3, but the other one has 3 3s.
3 times 3. Factor 9.
So, Miss Rice, we add.
Oh my god, it'll be 1.
It's a big number. Say it again? 3 times 3. So the 27 would be 3 times 3 times 3. All right. How did you guys factor 27?
7 times 3 times x times
Okay, so that's 9 times 3. What did you do about the 9?
3 times 3.
So 9 is actually 3 times 3. So I'm going to erase that. I'm going to put 3 times 3. Okay. And then we also have an x. Okay, so what's our common denominator need to have?
7 times 3 times 3 times 3.
times x times x.
Okay, so we need a 7.
Times 3, times 3, times 3.
And why do we need 3
So
3s?
that has the most.
Yeah, this side only had 1.
Times x.
This side had 3 of them, so we needed the most. Whichever side win. Okay. This had 2 x's, this has 1, so how many do we need? 2. Yeah, where'd the 9 go?
3's. It turned into 2 3's because it still ends up being.
Yeah, so we started off, we said that 27 was the same as 9 times 3, and we took that 9, and we said that was 3 times 3. Even if you left the 9, it was okay. Yeah. All right. Did anyone figure out what 7 times 3 times 3 times 3 is?
189 x squared.
All right. Leave yourself a couple lines. Here are the more advanced problems. We're moving on. Ready? All right, so what is different about these denominators compared to the other ones? What do all of these have? They all have pluses or minuses. So this is a group, this is a group, that's a group. And once you start to see those pluses and minuses, what are your methods for factoring that you're allowed to have? What methods for factoring? Okay, so I'm going to write a note to myself, GCF, diamond, difference of squares. Those are the only methods I have for factoring these denominators. I cannot separate this and say, oh, that's 5 times p. Can't do that because my only methods for factoring are GCF, diamond, difference of squares, and potentially a slide divide, which I did not do to you. So for number 4, how do we factor that first denominator? It's not difference of squares. It's GCF, yeah, it's the other one. So we have a GCF of what? 5. We can take out the 5. And then what is left over? P minus 1, good. Can P minus 1, this one over here, can that be factored? No, so that is the factor. So the first fraction, the denominator has 2 factors. One of them is 5. The other factor is P minus 1. The right fraction only has 1 factor. It's just got the P minus 1.
So is it 5 minus 1 and that's the common denominator?
Okay, so Katie thinks the common denominator is 5 and then also P minus 1. Is she right?
Yes. No. Where?
Is she right?
Yeah.
Why are there not 2 P minus 1s? I see 2 of them. Each side only has 1. You only need 1 because each side only has 1. So P minus 1 only has to be used 1 time. And then we also need that 5. What do you notice about number 5?
It has different, oh wait, no.
That's P plus 5. What do you guys see about those denominators? Is there GCF?
Yeah, 5.
Is there 5, but is it in both pieces? No. So no GCF. Is there a diamond to be done? No. Difference of squares? No.
No.
These are completely factored as they are. Yep. P plus 5 cannot be made smaller with its factors. 5P minus 3.
So the answer is just plus 5 times 5 minus 3.
Yeah, so if you look at this factor is completely different from that factor. I see that they have a 5 in common, but they're not the same. The factors are different. And so I'm going to say my common denominator needs both of those. So common denominator is going to need the P plus 5. It's also going to need the 5P minus 3. It's going to need both.
If it's a common denominator and they don't have one, why is the common denominator 0?
So it's when you look for the common denominator, you're not asking the question what is already in common. You're saying what denominator could I put together that has everything for both of them. So you are making it happen as opposed to saying what already has happened. Yeah. All right. Number 6. Is number 6, are those denominators completely factored already? No, we got some factoring to do. Go ahead and factor number 6. Take some time, factor number 6. Those denominators, these ones take a little bit more energy. How did you guys factor this first one? Diamond. So multiplies to negative 12. Multiplies to negative 12, adds negative 1, negative 4, and 3, I heard. So the first fraction has 2 factors. One factor is n minus 4, the other factor is n plus 3.
The second one is
Difference of squares.
Plus 4 and minus 4. The way you would write it is n minus 4 and plus 3 plus 4.
Okay, so I see a factor that's already in common, so that needs to be there. N minus 4. Why are we going to use one of them and not 2 of them? There's it's already common, right? There's already 1 in each, so we're good. We got it.
Plus 3 and then plus 4.
Yep.
All right. I'm going to give you guys 3 more problems that are like these, and I'm going to leave you some time to work on them. So we're not going to go over them one by one. I'm just going to leave you some time to go over those, okay? I do. I want you to keep leaving space because this is just the first part of what we're doing today. We're about to start getting the common denominator for each fraction. All right, so we're going to do a little bit more work today. All right. Can I switch pages? Yes. Okay, so here's the other 3 problems. All right, how did you guys factor the denominators for number 7?
Number 7 is x plus 2, x plus 2.
Okay, so when you use the diamond method, you find x plus 2, x plus 2. How about the factoring for this one?
It's x plus 2 and x minus 2.
Perfect. So if you look at this, I can see that there are x plus 2's on each side, but how many of them do I need in my common denominator? I need 2, because this side only has 1, but this side has 2 of them. 2 of the same factor, so your common denominator actually needs 2 of them. Remember, whichever side has more wins. And then because this one has an x minus 2, we also need that. Yeah.
If both sides have something, you only put it down one time, right?
It depends. Like this one, they both had at least one of them, but this one happened to have 2, which is why we wrote it twice.
But you have to have 2?
You have to have 2 because this one had more. Whichever side by itself has more, that's what you have to
They
do.
both had, I was looking at people wrong. I thought it had, I thought they both had x plus 2, x minus 2, so.
Okay. All right. We good on number 7? Yeah? Okay. Number 8. What type of factoring was this one? GCF. So you take out a GCF of what? A. And then what's left over? A minus 5. Right, Courtney and Pedro?
Yep.
Is that what you guys got? Okay. And then 2A minus 10, what type of factoring is that?
GCF of 2.
GCF, take out 2.
A minus 5.
So for the common denominator, what do we need?
Times A minus 5.
Yeah, we need a 2, we need an A. Each of these had that factor. Just we need a 2, we need an A, and then we also need that common factor that they already have, the A minus 5. Why do I only write A minus 5 one time?
There's only one on each side.
They each only had one of them. Okay. All right. How about the common denominator for number 9?
It's 5.
5.
Is K plus
5, and then also K plus 5. So the denominators were each just one factor. So this was a plus, so it had parentheses around it. You can't factor it down any further. So they each only had one factor. So that means my common denominator has 2 factors, one for each. Okay. Whew.